So today I'll be talking about an important component of civil engineering. This is environmental engineering. And in environmental engineering, I'll be telling you specifically about air pollution. Air pollution is an very relevant problem and is a reason for global warming and climate change. You can hear about air pollution episodes of Delhi, of any other city where people die. Bhopal gas tragedy, for example, cause, is a reason for air pollution. And it is nowadays there's a lot of thing about global warming and climate change. So air pollution is an important aspect. And one of the important uh, criteria pollutants are those pollutants which are uh, being shortlisted by the pollution control boards, and the pollution control board that we have is the Central Pollution Control Board. There are many criteria pollutants like SOx, NOx. SOx stands for sulfur dioxide, oxides of nitrogen of sulfur. NOx is NO2, NO3. But what I would like to talk specifically is particulate matter. And CPCB has, in its guidelines, have categorized particulate matter as PM10 and PM2.5. So what is PM10 and what is PM2.5? So any particle that is less than 10 micrometer of size is PM10, and any size that is less than 2.5 micrometer is known as PM2.5. So in order to understand like why they have shortlisted on, or why they have categorized in this range, we have to look deeper. And if you see, like few years back, CPCB didn't have this PM10 and PM2.5, the Central Pollution Control Board, or for the matter, the USEPA, United States Environmental Protection Agency, didn't have PM10 and PM2.5 as their standards. They had a different term which is total particulate matter, because they were concerned about the total mass that is being coming out from different pollution devices. But then they realize that rather than the total mass, if they focus on one particular size, which is PM10 for example, is this part which is respirable. So one of the terminologies that is being used for PM10 is RSPM, which means respirable suspended particulate matter. Suspended particulate matter is less than 30 micrometer size. RSPM is less than 10 micrometer size. And then one more subdivision of PM10 which came out is PM2.5. So between PM10 and PM2.5, what's the difference? The difference is that the PM10 majorly comes from natural sources like volcanic eruptions. It can be any kind of dust. So these are all PM10. Whereas PM 2.5 comes from anthropogenic sources. So what do we mean by anthropogenic source? Anthropogenic sources are majorly man-made pollution sources like combustion devices. For example, cook stoves, vehicular emissions, industries. So these kind of emissions that come out are are mainly classified into PM 2.5. So one of the thing that the standard talks about, CPCB standard talks about, for example, for PM 2.5, it talks about like the regulation is for one day average should be around 60 microgram per meter cube or 80 microgram per meter cube. So how do you define that? So in order to do that, so they have, suppose I'm doing a sampling and here is a pump and you have a rotameter here, and you have this pump going in here because the pump is sucking, so it will go something from here, sorry, uh, and it will take it out like this, and this is the inlet here, and this is a filter. So this is the part where PM10 or PM 2.5 or SPM gets collected. So and now this is being open to the atmosphere, like any kind of source is there. For example, if you have a candle here, so the particles that are coming will get deposited here because of suction. It is going through the rotameter and then getting collected, and then the pump is sucking in. So this is the part where most of the mass gets collected, delta m. So there is basically inside this, if you see, there is a filter paper here, and over this the mass gets deposited. So this will have a certain flow rate q, and you will do it for a certain time t. So now the concentration that you get is basically delta m by q into t. So if you see the mass collected of this particular, it will be somewhere in microgram. So delta m will have a mass of microgram. This q will be, say, suppose the normal sampler that we use will have liters per minute. So it will be 5 liters per minute, 5 liters per minute. And this time duration, it can be either 24-hour or 8-hour, or any duration that you can get to get a considerable amount of mass. So this will be around, say, suppose 24 into 60 minutes. So basically the concentration that you will now get is in terms of microgram, and you convert this liter into meter cube. So this will be in microgram per meter cube. That's how the normal standards are decided. So PM 2.5, if suppose somebody says they will only give you in the concentration range of 60 microgram per meter cube, or for 24 hours. Thank you.